Number 11, Aaron kicked the soccer ball with an initial velocity of 55 feet per second, an angle of 38 degrees with the horizontal. After 1.2 seconds, how far has the ball traveled horizontally? So obviously we should have an S right there at 1.2 seconds. But here's how we're going to solve this problem. We look over at the formula chart and we're going to go to projectile motion. And we're going to use these two equations. So here's what we know about this, is that when we take the equation, it's always v0 cosine of theta times our time. And the y is going to be equal to negative 1/2 gt squared plus basically the same thing up here. Initial velocity times sine of theta times time plus the initial height. Well, let's see here. Aaron runs up and kicks the soccer ball at a speed of 55 feet per second. So the soccer ball comes up and it's going to go over here like that. Let's try to make this actual parabola though. There it is. And so this parabola, it comes off his foot when he kicks it like a vector. So when he kicks it, it actually comes off straight like that, like a vector. And here's what we know about it. It's 38 degrees from the horizontal. So if you made a line here with the ground, this is 38 degrees. And it's gravity that's pulling this down. This is what makes it not just be a straight line like this. And he kicked it at 55 feet per second. So that'll be 55 feet per second. And anything else to include? No, that looks like it's it. And so we want to know how far does it go after 1.2 seconds. So now we just fill in our information. We know that the initial velocity is 55 feet per second. So now we'll go there, and now we'll go there. We also know the initial angle is, or that angle is 38 degrees. So that's going to replace that theta and this theta. So we'll go with 38 degrees there and there. 38 degrees here, 38 degrees here. Since he kicked it from the ground, the initial height is simply a 0. And now we got to talk about gravity. Since we're in feet, we go to the formula chart and we look at the gravity. We want the 32 because it's in feet, not the 9.8, which would be meters. So here for G, we're going to replace that with 32. So I'm going to erase this G and replace it with the 32. Right there. Now let's go to the calculator and see what we get. So I'm going to go to Menu, Graph Entry, and choose Parametrics. The equation was 55 cosine of, was it 38 degrees? Let me go back one more time. Yes, 38 degrees. Read buttons down here with pi. And then I put the t on the outside. That's the number one mistake I find that people make, is they don't put that t there. And then we do 1/2. And gravity is 32. It's negative 1/2, that is. And then t squared. Now the number two mistake people make is they don't put a plus here. They just multiply the next. And so we need to add 55 sine of 38 degrees. Again, degree symbol. Put a t on the outside. And then we would have a plus 0, but you actually don't need that. Now when we kick it, we're not going to kick in negative time. And this will probably be way longer than the ball's ever in the air. So I'm just going to say like 4 seconds. Like that. Now here's the fly of the ball, but I want to be able to see it all. So I'm going to window zoom, and I'm going to zoom fit. And here's the flight. So you can see this was way too much time. The ball would have hit the ground and kept on going. But what we have to find is how far has it traveled when we get to 1.2 seconds. So we're going to do graph trace, and I'm going to look back for when t is 1.2, which is right there. At 1.2 seconds, the ball's flown 52 feet horizontally and 17.6 feet vertically. What are we supposed to find? How far has the ball traveled horizontally? So when t equals 1.2, value I had over here was that we had 52 for the x and 17.6 for the y. Horizontally, it's traveled 52 feet. That would be your answer.